Hi, my name is Jeremy Schulman. You can find me on Twitter as Network Automaniac. And in this tutorial, we're going to do part 2 of using Python Async Io to interact with the IP Fabric API. So just as a recap where we were in part 1, and if you haven't watched part 1, now would be a good time to stop this video and go watch that. In part 1, we had created a coroutine called fetch device info, which would log into IP Fabric and then perform a series of fetches from tables concurrently. So we were using the Async Io gather method to obtain all of this data concurrently. And so just to show that where we were when we left off, I've copied what we had before into a new file called demo2 just for the purpose so that we can kind of work on it. And I am now going to use IPython as I did before for demo2. And we are going to get the results by awaiting the fetch device info coroutine. And we're going to say example leaf1. And we can see what our results are. We have a list, and we can see the length of our results. We have 4 items. So as before, the first item happened to be the device inventory record, and there's only one element in that record. So we're going to do a couple of things in this tutorial. We're going to do 3 different things. The first thing is we're going to decouple the return data from the way that the function itself works. So what I mean by that is this gather is running 4 coroutines concurrently, so that just as I've shown, the 0th element was providing the inventory record. Well, we don't want to have to make the caller of this function know that little detail, because somebody may go into this function and change the order of what's going on in here, and that would have a ripple effect to the caller. And that's kind of what some people call a leaky abstraction, right? And we don't want to have a leaky abstraction. So what we're going to do is, rather than just return these results as a list, we're going to return that results as a dictionary. So for example, we could say, rather than returning the results as a list, let's do this. Let's say that the inventory record, or what I like to call the facts, is the 0th element. And let's say that we're going to return the host name, which is going to be the facts host name. And we know that there's only one record in the inventory. So then we're going to have facts, and that will be our facts. And then we're going to have interfaces, which will be our results sub1. And we have our VLANs, which happens to be our results sub2. And we have our IP addresses that were bound to interfaces as results sub3. So now when we return this, we've decoupled the structure of this mechanism to the key value pairs that we want. So just to demonstrate that, we'll go and do our results is equal to await fetch device info, example leaf1. And now if we look at the results, we can see that it's a dictionary, and the results has these keys. So I could say, results host name, right, and results facts. So we've decoupled that. Now the next thing we want to do is, well, what if we want to run multiple fetch device infos concurrently? So this is really kind of what this device, this fetch device info does, is it concurrently gathers everything we want to know about a device. But let's say we want to do multiple devices and fetch them concurrently. So what we first need to do is we have to refactor this coroutine so that we can pass in the IP Fabric client and use that for multiple calls. So let's do that. Rather than creating the IP Fabric client inside this function, we'll use IP Fabric client. We'll just kind of pass it in. And we don't want to log in and log out each time, so we will get this. Now, what we're going to ultimately do is we're going to, fetch devices for a given site. So just for the sake of mapping this out, I'm going to call this an async def fetch site. and we'll give it the site name. And what we know we want to do is we want to call, fetch device info a number of times. So what I'm going to do is I'm going to, first create the instance for our IP fabric connection. Like I did before, I could create the instance, log in and log out, but I'm going to use what's called a context manager in this case. So we can say async with, and in this case we could say IP fabric client as IPF, and what that does is anything now inside of this inside this indentation here will be implicitly the IP fabric is opened, and when it's done it will be implicitly closed. So I could say fetch device info IP fabric and then example leaf1, and then I could do fetch device info IP fabric example leaf2. So I'm just going to do 2 devices. I'm not going to do the whole site just yet. We'll get to it. But let's say I want to pull this data concurrently. So using the same async IO gather, I could say we'll call it results is equal to await async IO gather, and here we're going to gather these 2 results, and then when we're done we can return the results. Okay, so again we'll fill in this site here in a minute. We're just going to take two devices. For example, leaf1. Example leaf1 for example is this, and leaf2 is that. So now if I execute this, what this is going to do is it's going to do both of these concurrently, but it's going to return the results only when both of them have been completed. And we're going to come back to that in a minute, but what async IO gather does is it again does all of these things concurrently and returns the results only when everything is completed. So let's test that out. We'll say results is await IO. In this case, it's going to be fetch site, and I really don't care what the site is for right now. And now we're going to say, well, what is results? It's a list, and how many are in there? There's 2. And if I look at the first one, I'm like, well, what is that? I can see that it's a dictionary. So we have host name, and we also have host name. Okay. So if we want to, combine a couple of the techniques that we have, then let's say we want to do it for a whole site. So in this case, what we first want to do is we want to get the records from a IP fabric fetch table. So we want to await the results. And fetch table is a function or coroutine really that is going to allow us to fetch any data from any table. And we kind of did examples of this here, where we were calling the post directly and using this API or table API decorator. So as an alternative for doing this approach, we could simply use something called fetch table, and fetch table, you give it the URL that we're going to fetch on, which we'll fill in a second. We can say which columns that we want back, just like the table API decorator. So in this case, all I really want is host name. And then the filters that I care about is the only the site name is equal to some value that we will provide a site. Okay, so the only thing I'm missing here is the URL. So for that, I'll go to my IP fabric. I'm in the devices table here, so I can look at to see what it would be. And it is tables inventory devices. So let's just populate that there. And this is going to give us all of our records. So, and really all we've asked for is the hostname values. So if I were to put a breakpoint here just to kind of illustrate this, we will do await fetch site. And in this case, the site name is going to be L77. And you can see I've hit my breakpoint. And if I look at the records, I can see that I have, some number of records. And in each record, there's a hostname field and a value. Okay, so now that I have this, I could iterate over these records. And I could say what I want to do here is I want to do this fetch device info gather based on a host name. And that host name is going to be for each host name in records. And really, it's not the host name. I'm really just getting a record. So what I want from the record is the host name. Like that. OK. So what's happening here is what I'm passing gather is essentially a generator, because I'm creating a list of these coroutines, or generative coroutines, which it's going to expand. So this will give us back our results, which will be 11 records. And I'll show you that. So we'll come into the demo. We'll say results is await fetch site. Oh, got a bad yield coroutine. Okay, so it will not allow us to do this as a essentially as a generator. So let's fix that. We'll just say tasks is equal to this. And the reason why this is, let's see, fetch device info for record. OK, yep. And so the reason why this is what gather expects is it's not expecting an iterator. What it's expecting is just kind of I'm going to say the word list, but really it's just a number of items. Let's see if I can show it here, where you can see in this panel, and I'll make this bigger. It's basically looking for, a coroutine followed by a comma, a coroutine followed by a comma, a coroutine followed by a comma. So it's not looking for an iterator or a list. So because of that, what we end up doing is I'll create a list and then I'll flatten that list like this. So that turns, a list into a flattened list of those comma separated, coroutines. All right, so let's see if that works. Await fetch site L77. Okay, now that completed. And you can see that we have 11 of our records, and our first record, host name results, sorry, is that, and the last record is leaf 1. So if we looked at our table here, we can see that the first one is 73 core 1. Let's see, I'm gonna make this a little bit bigger. And the last one is 77 leaf 1. Okay, so what this has done though is it's blocked again. We're blocking here, waiting for all of the results. So there are some cases where you might want to block waiting for everything, and there are other cases in which you want to handle the results. You might want to handle the results as they are happening, meaning, I want to get a device worth of content, and then I want to process it immediately. I don't want to wait for any other device. I just want to, get that device's content and then process it immediately. And there is a way to do this called as completed. So I'm going to show you a new Async Io function called as completed. And the way this works is you can do it as a for loop. You could say, for next, I'm just going to create a variable called for next done in Async Io as completed. And what this is doing is I'm going to feed it, these tasks. So in this case, I can feed it a list. It is meant to take a list. So if I were to show you that here, you can see that as completed takes an iterable. So this is one of the differences between as completed and gather. So what this does is it will give you, what it gives you back is a coroutine that you must await on to get its results. So we could say results is equal to await next done. And what this is this is the result of this task. Okay, how as completed works under the hood in order to feed you this thing that is done in this way, I'm going to talk about in a minute. It gets a little complicated, but for now, just think of this next done as a way in which you get back, you're able to get back the results of what you feed into as completed. So here I could say this is going to be a record of results. So I could say, print host name is rec host name, and I'll turn this into an f string. I'll say rec here. Okay, and for right now, I'm not going to return anything. We'll just leave this as it is. What am I missing here? Host name is rec host name. Needed the little brackets. Okay, so let's try this. Await fetch site L77. So you can kind of see that these popped out and they staggered a little bit. So I know that's happening really fast because the IPFabric API is very responsive, but these this printout is happening as they occur, right? And if I wanted the caller of fetch site to do something with the data as it was being returned, I would have to provide that data to the caller right here. So the way you do that is you can yield that data up. I apologize for this documentation keep popping up there. What we can do is we could yield this record. And what that does is it turns this coroutine into a generator. So let's do that. The way that you then have to interact with the data is slightly different. You can say async for record in fetch site L77, and then what's happening here is as the data is coming in, I can do something with it. So again, if I wanted to print it, I could say host name is rec host name. And you can see, again, what's happening here is as fetch site data has a record for me, I get to do something with it. Okay, so now what we're doing is we're concurrently fetching data and processing it immediately as we get it rather than waiting for all of the devices to get fetched as a whole. And again, you might ask yourself, well, which method do you want to use? It really depends on your use case. For example, if you need two devices of data together in order to process them, like you might do for, say, a redundant pair of top of rack switches, you might want to get both devices together. Or if you want to do something for every spine in a leaf spine fabric, but you can process a spine, as an independent device, then you can just say, give me all the spines, and as you get the data for the spines, you can then yield up that data and process it. Okay. So this is a fairly sophisticated pattern, but one in which you might find yourself using with Async Io quite a bit. So just to recap, the real differences here is as completed is giving you data, as it's being available and not waiting for everything to get done, as compared to the Async Io gather, which is I don't want to return until I've completed all of these coroutines together. Now I'm going to move into a slightly even more advanced mechanism here, because what Async Io as completed is doing under the hood is it's taking this list of coroutines and it's packaging them up in a certain way that allows them to get done and get processed as they're done. But what this next done variable is it is not this fetch device info. So next done is not this coroutine. And you might be asking yourself, well, why do I care about that? Why do I care about whether or not it's the coroutine that I fed into it? And the reason is the following. if you have done any kind of multi-threading in Python, not using Async Io, but just with threads, they have a similar function or method called asCompleted. And what that allows you to do is, in a very similar way, to process the result of the thread when it's done. But in order to link together the data that you put into the task and to be able to fetch it back again, the technique is to create a dictionary that maps the coroutine with some input data. And so what that would typically look like is this. I might say, rather than making tasks a list, what I'm going to do is I'm going to turn this into a dictionary. Now, the key of that dictionary is the coroutine, okay? And the value is, think of the value here as your input data. Now, I'm just going to use rec hostname as kind of a placeholder. But this is usually a dictionary. You know, the value of this key is usually a dictionary that you want to get back. There are use cases for this, so that when you're done, when you get the data here as it's being processed, you want to be able to fetch, you know, information about that task, you know, so that you can kind of link that data back together. That's getting really annoying. I'm sorry. So normally, what this next done here is this would be. I gotta stop this. There's gotta be a way to turn this off. All right. Normally you would use this variable next done to be an index into this dictionary, and it would return you back this result. But as I said earlier, next done is not the coroutine that you fed into it, right? What next done is essentially some kind of construct that is a result of as completed, so that you can get the result of that coroutine. So I said a lot of words, but I'm going to show you the way in which you have to go about creating essentially a wrapper so that you can get back the data you fed in. And I know this is going to look really complicated, but just kind of hang with me here. What we want to do is, I had to draw a picture of this. What we want to do is, we have this fetch device info, and ultimately we want to get this fetch device info back out so that we can use it as an index into our task table, so we can get the requested kind of information we're associated with that task back out. So in order to do this, and what I'm going to show you is very advanced, but this is what you have to do in order to achieve this kind of use case, is we're going to create two constructs. We're going to create what's called an Async Io Task, which is going to be bound to this coroutine, okay? And what a task allows us to do is associate a callback to execute when that task completes. So when say, for example, fetch device info completes, then it's going to trigger an event saying that it's done, and when that's done, it's going to execute a callback that we are going to associate with it. Now, what is that callback going to do? Well, we're also going to create what is called a future. And a future is, again, something that you can wait for. And in this case, what we're going to do is we're going to create this future, and what we're going to do is we're going to set the result of that future to return the coroutine, this coroutine task, okay? So when this completes, it's going to basically fire a callback that basically is going to call the set result, and it's going to then set the result of this future. Now, wow, that sounds really complicated. Well, why would you want to do that? Well, rather than giving fetch device info and putting it into as completed, because what we get out is this next completed thing that has no relationship to the thing that we put into it, what's going to happen is next completed is going to pop out, and because the result of next completed is going to give us the result of this future. It's going to be our coroutine task, this original coroutine task, right? Now, what that's giving us is the task. It's still not giving us the fetch device info. It's giving us this instance, which is the coroutine task. But a coroutine task, or an Async Io task, has a function called getCoRow, which will give you back the original fetch device info. So this is the way that we get it back. And again, we're doing all of this just so that we can index back into a table or dictionary, so we can get some information, about it. So let's implement what this kind of looks like. So we have these tasks, and I'm going to leave them kind of like, let's see, I'm going to leave it kind of like this, but I'm going to change, I'm going to create another function here, and I'm going to call this, we'll call this make awaitable. Okay, and so we're going to pass it a corow, a coroutine, which is really going to be this. So I'm going to call this, make awaitable. Okay, and what we're going to do is we're going to have our corow task. This is an Async Io create task, right? So that's that. So create task, what a create task is doing is this is the step right here. And when you create a task, it's going to put it on the Async Io loop for execution, meaning it's going to schedule it for execution, which means it's going to run at some point. Now we need our await future, or our what did I call it here? Await task. So await task, and this is going to be an Async Io create. This is going to be, actually what we want to do is we need a loop create future, which means I need the loop. So I'm going to say loop Async Io get event loop, and this is going to be create future. Okay, so this is going to give us the future that we want, and then we're going to say coroutine task set or add done callback. And again, when the coroutine finishes, what that means is it's going to call this add done callback, and it is this await task set result that we want it to call. Now, the way add done callback works is whatever you pass here, this is going to get executed, and the first parameter that gets passed to your callback is the task itself, this coroutine task. So what's going to happen is await task set result is going to get called, and the result is going to be this coroutine task instance. So what this 3 lines here does is it sets up this little box here, and now we need to return the await task. So that's what gets it fed into as completed. So we'll say return await task. Okay, so now what happens is this when we finish this, what this is really giving us back is our coroutine task. And what we want from that is the actual original coroutine, which is really we'll call this the fetch device info task. Corow task get corow. Okay, and that's the task. That was the task that was created here. Now the reason why this is being squigglyized here is because it's a name. It's kind of overloading the name. So I'm going to do this. I'm going to call this made corow, and this will be made corow task. Okay, and then since this is a task, what we want to get back is the result, right? So we're going to get the result is FDI task, and this is, we're going to get back the result. Okay, so now that I have this, I'm just going to call this co-row. Now that I've got this co-row, coroutine, I can use it as a lookup into this dictionary, because you know what this is right here is this is your key. Let me take that back. Actually, what I need to do is I need to leave this to be the co-row because I do want it to be that. And so really what I want to do is I want to say as completed await, I want to say make awaitable co-row for co-row in tasks. And that's going to be a list. All right. Yep. Okay. So this is going to, you know, take this coroutine, turn it into a awaitable that I can feed through here. And the reason why I just changed this is because I want to use the original co-row as a lookup into this task dictionary. I know this sounds really mind twisty and bendy, but there really is a good reason for doing these things. Okay, so now that I've got the FDI co-row and I got the results of that, I can go and get the value that I've associated with the co-row. Now I know in this case it's just the same thing as the host name, but this is just an example. So I'm gonna just call that my request data. Request data is equal to tasks. I'm going to use the FDI co-row as the lookup into this table. So I'm just going to call this results data. So now I'm going to yield two things, the request data and the results data. So now when somebody calls, you know, this, what they're going to get back is, you know, the original data as well as the result data. Wow, that was a lot. So let's see if that really works the way I think it works. So now we're going to say async for request response in fetch site L77, and I'm just going to put a breakpoint in here so you can kind of see this. Result coroutine task. Let's see. That's my coroutine. That's the task. I think this is, I may have had that slightly backwards. Let's see. Okay. Request. So you can see request was the hostname value, and the response in this case should be the same, right? Response facts. You know, that's the entire record. So I could say, well, what are your VLANs? Response. That particular device had no VLANs. But we could do something like, let's make a demo, async demo. We can say async for request response in fetch site L77. We could do print host name is, in this case the host name was a request data, has len response, let's say interfaces. Let's just say print out the interfaces. Okay. So now we could do something like this, async demo. async await async demo. Oops, sorry, await demo. All right. So now, it's basically presenting us the data as it arrives. So, using the as completed, we're getting the request data that we bound to the original fetch function, and we're just, showing that we got some data out. So again, in recap, because this is a very advanced pattern, but it is a pattern that if you've been programming in Python threads and using as completed, this is something you're going to want to know how to do, because when they implemented the Async Io as completed, they didn't make it match the kind of the behavior of the threading model. And to kind of transition from using threading to Async Io, it's this little trick here that you need to understand in order to get the same type of behavior of using a dictionary to map your request information into or associate with the actual thing you're doing. So in threading, this would have been a thread, creating a thread, and this would be some information about that thread that you wanted to get back later. Okay, so to recap, what next done is just a placeholder, and it returns back the task. And the task is what has the result that we really wanted. And the task gives us back our coroutine, which we're using as our lookup into that table. Okay, so we'll just look at this again. This is the result of next completed, and that's how the chaining works. So hopefully that wasn't too mind-bendy. It took me a little while to kind of wrap my brain around this particular pattern. So hopefully it's an interesting thing to look at, think about, understand, especially if you have been doing some Python threading and you're now getting into the Async Io. So if you have any questions, please feel free to put them up under the video. All right, thank you.